So in the last video we have seen about how an ordinary diode works. But when it comes to LED, you cannot expect the same operation because it has to emit light. So the real case is that whenever the electron and holes is being moved, so whenever the electron and holes moves from one place to another, or I can say in clearly, if an electron is being accepted or it is being released, an energy will be released in the form of photon. Photons are nothing but bundles of energies which are emitted in the form of light. So the color is being determined by the fall of electron and also the energy level of the photon. So this is how the light is being emitted from LEDs. So if we want to get different colors in LED, then the wavelength should be ranges from a different value. For example, if an LED emits red color, then the wavelength range which is being given in nanometer will be 620 to 645. Similarly, its efficiency will be 72, which is luminance per watts. And also, if we want to obtain a red and orange color, red mixed to orange means, then the wavelength will be 610 to 620, which is of efficiency 98. And for green color, it is 520 and the efficiency is 93, and so as for the other colors. So we have different types of LEDs also. So LEDs are produced in a variety of shapes and sizes. The color of the plastic lens is often the same as the color of the light emitted. So the epoxy case which is being the enclosure for the entire construction determines or it depicts the color of the LED. If you have a red color, then the epoxy lens will be red in color. If it emits orange color, then the epoxy lens will be orange color. So the different types of LEDs are traditional inorganic LEDs, multicolor LEDs, bicolor LEDs, tricolor LEDs, organic LED, miniature LEDs and high power LEDs. And the LEDs are also available in different shapes and size. The modern high power LEDs such as those which are used for lighting and backlightings are generally found in surface mount technologies. And also the different sizes of LED ranges from different millimeters like 8 millimeters, 5 millimeters, 3 millimeters, etc. that you can see in the screen. So the different size of LEDs can be used for different purposes, like for indication purposes and for displaying letters, alphabets and all. So it finds applications in different areas. So first we will see traditional inorganic LEDs. So this type of LEDs are manufactured from inorganic materials. So these inorganic materials are compound semiconductor materials such as aluminum, gallium arsenide phosphide and all. So these are inorganic materials. Whereas when we see about multicolor LEDs, we have bicolor LEDs, tricolor LEDs and more. So bicolor LEDs means the LEDs will emit two different colors. So two different LED emitters will be placed in a single case. So that you can see in the picture shown. So you have two different LEDs. One type consists of two diodes connected to the same two color types. So the current flow in one direction emits one color and the current flow in the opposite direction emits the other color. Next we'll see about organic light emitting diodes, which is the OLEDs. The OLEDs are most commonly used in display technologies such as computer monitors, televisions, mobile phone screens, etc. So we have seeing few pictures of the applications of OLEDs. So in all the screens we could use OLEDs. So OLEDs is a semiconductor which contains carbon, which is organic also. The OLEDs uses one or two polymers or small molecules. So this is the structure of OLEDs. So we will discuss about this OLED in detail in the next video. Thank you for listening.